I'm going to show you something and that's interesting. So step 9, we end on this one. Step 8 is here, we go to step 9, step 10. But we're going to go down. And we're going to solve for 13, because when we're coming out of here into the 4x4, which I haven't started yet, under the V, I want to solve for this cell. So I want to look at the relationship. So we're going to go from here to here to here. We're going to go 1, 2, 1, 3, 1, 4, 1. And we're going to end on this red bubble. There are 7 cells, they sum to 13. Cool. 13. Now let's solve for 28. So we ended on the 1. Okay? Now, just out of sheer coincidence, I'm just playing around here. If you go 5, 1, at the same time, if you go 3, 4, 2, those are 12 cells. 13 and the now 15 or 28. They sum to 28. Now we ended there. We have 28. Okay. So we can go to 3. But I'm not going up because that doesn't exist. Okay, it only comes down from this side. So I'm going to go 3, 1, 4, 1, 5, 1. Now I'm not going to go back 3, 4, 2. I'm going to go back 3, 4. Like an n-1 kind of way. Those are 20 cells. You have the 12 cells from before for the 28. And then you have 12, 13, 14, 15, 16, 17, 18, 19. 20 cells. Added up sums to 50. 50 is here. Huh. Where do we end? We ended on the 3, 4. So we ended here coming from this direction. So we've ended here first. We've ended here second. We've ended here third. Kind of looks like making a V. And then we're going to see what happens. So take our 50. 2, 3, 1, 4. So we ended here. So let's go up. 2, 3, 1, 4. Now we're going to go 1, 5, 1, 6, 1, 7. Now from this 6, we're going to go to the 5, 5, like we did above with the 2, 3, 4, and now the 3, 4. Now we're n-2 away because we used to go 3, 4. We ended here with 3, 4, 2, 3, 4, 2. Then we ended with 3, 4, 3, 4. 1 minus that would kind of connect it to the 5, I'd say. So the 4th place we ended is here. If you take these numbers, 2, 3, 4, that's 10. Or 1, 2, 3, 4 sums to 10. 5, 5 sums to 10. And then you have an 11 and a 7, which is 18, 19, 20, 21. 21, 10, 10 is 41. 41 and 50 is 91. 91. Want to find 110? It's pretty easy. So we ended here. 91. Again, it's like 34 cells. I guess 50 is 32 cells. I didn't say that, I guess. 32 cells and sums to 91. There's a lot of shit there. It's a big jump from 20 to 32. 20 plus 12 plus 20 is 32. Nice. 1 of 7 of 13, 12, 13, I don't know. Alright, so we ended at the 5. We need 19 to get 110. We know this is 110 here. How do we get 110? over here, the only way I can think about it is I want to start making the infinite knot that exists here. So I'm going to go down to the 6 and then over to the 13. 6 and 13 is 19. 19 and 91 is 110. And you have 34 cells. Now what's happening here is this 8 is the corner of the infinite knot. It uses the 50 and it goes like that. That's kind of like what it does. So I'm thinking that this last step here is the reasoning that this plant or flower kind of shows you how you're supposed to bury it in the ground a certain depth. Maybe the seed should be in the middle of your dirt so that some can go up and some can go down. There, that's what I end with. I hope you think this is interesting, because I'm a little mind blasted right now. Yes, I have a laptop now. Interesting. I have nothing on it. I haven't even used it. But I do have the internet. And I know I have to apply for EI, because apparently I need employment insurance? Isn't it supposed to be... Is it EI? Employment insurance. I'm unemployed, so is it unemployment insurance? Whatever it is. Irregardless, I guess, which is not a word. I need to figure out how free money is going to come to me so I can sustain life. At the same time, I understand I have to make a call to make things happen in actual life for other people. But today is Sunday. I don't remember the last time I had a Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday off, so I'll do that tomorrow on a Monday. Can't really hang out with people and talk to people because they don't give a shit and they don't care. And I can't really talk about bullshit of life and the news and all that because I don't care. Pattern changes here. It's not reciprocal here. It takes this amount of derivation just to get that line to come out. This line coming out here is just as important as the one above where the blue one was coming out. Step 13. Step 13, guy. It's just this one's going this way, and step 13 was showing you that it was showing you this line. I don't know if you see that. And now we're going, wow, now we're going to here. From here. That's very interesting. 1, 2, 3, 4 segments away. There, 42. 4 segments with your flying. I don't know. But it's very interesting. Your intersection points are interesting. Like where they cross and make new this is a new singularity. That's a new singularity. That's a line crossing that can be crossed. That's a line crossing. That's a line cross. Like these could all be crossed by other lines and create new singularities of intersection points on a matrix, and that creates a new node, and that changes the math a little. No one seems to understand this. I just derived this a different way by looking at patterns. I don't know what the formula is, but I know it's doable. Is that impressive enough, or do I have to go down to the next number? Because I really don't want to ring around the posy the 340 guy. Kinda don't. Because it changes. I probably got to get into the 1x5 at that point. It's changing. Look what's in the V now. Look what's in the V here. Your 69's right here. Your pi is right here. This is the two chunks. This one will be in a hole.